saying, so the R table saying if R is between 0 and 0.25, then there's like no correlation. And then if R was between 0.25 and 0.5, then it was weak. If it was between 0.5 and 0.75, it was moderate. And if it was between 0.75 and 1, it was strong. And the one thing I forgot to include here was this is the R value and then the correlation strength. My horrible handwriting because I'm going fast. The other thing I forgot to mention is R could be negative as well. And the only difference is if R is negative, it's just telling us there's negative correlation instead of positive correlation. Hey, there's a cop outside. That's weird. Sorry. Bird. So R could be negative. So if R was negative 0.8, it just means there's a strong negative correlation. If it was positive 0.8, it means there's a strong positive correlation. That was the only difference with the R values. But you should see an R value anywhere between -1 and 1. All right. The closer it is to 0, the weaker the correlation. The closer it is to 1 or -1, the stronger the correlation. That was what we talked about with R values last time and the R value correlation strength. And then how to comment on correlation. All right, strong, linear, moderate, nonlinear, things like that. Forgot to close my parentheses there. Bam. Find an equation for the least squares regression line. It might also say the line of y on x. That's another way you could see it written on an IB exam. Both of them mean the exact same thing, but it could be either one. And that's where we need to know how to put that in our calculator, or you need to be able to use Excel or Google Sheet to access those documents and do it. So you're perfectly fine on the test to open Google Sheets and type in equals Pearson, as long as you know how to do it. I would recommend learning how to do it on the calculator because, especially if you plan on taking the IB exam, because you won't have access to Google Sheets or Excel on the test itself. All right. And
if
then
I don't know how to do it on Google Sheets, is it fine if I know how to do it on my calculator?
Yes, that's perfectly fine. Yeah, you don't need to know how to do it on Google Sheets. I'm just saying if you don't have the calculator at all right now, you can do it on Google Sheets instead.
So that equation is just like the y equals mx plus b.
Exactly. That's just writing the equation of the line, y equals mx plus b. Basically, we're trying to find the m and the b values, yeah. And then the last part, interpreting piecewise functions. So can I write a piecewise function given a graph? Can I fill in the blanks? There was something like that on the homework last time over the weekend. Or if I give you the equations, can you sketch the graph of it? Vice versa. Interpreting piecewise functions, just interpreting the data. What's this data telling us? And then for certain values, what are those points? All right. So for our review today, I've gone ahead and added some good practice problems here. I think I've got everything on here that should be on the test. I'm really trying hard to make sure your review covers the test. Like if you understand everything on the review, hopefully there won't be any major surprises on the test. That's really the goal, okay? So make sure you guys take the reviews seriously, work through them. If you're stuck on something, then, oh, Mr. Street, I got to come to your office hours today, 2:30 to 3:30, and we'll work on that, all right? And then I think it's only 5 problems, but there's a lot of like A, B, C, D in them. Yeah, so I did 5 problems total, and then I have the book assignment number 10. So I think in class we should cover all 5 of these problems, and then I'll let you guys work on the assignment towards the end of class as well. But for right now, why don't you guys go ahead and start on problems 1 and 2, work through those, And I'll go over them in about 8 minutes here. I'm trying to think. There's 5 problems total. We got an hour left. So let me give you 10 minutes on these first 2 problems. I'm going to set a timer. And if you get stuck on any part of it, just ask the question. I'll help you out. And then we'll go over together in about 10 minutes.
The scale for the first one on the bottom.
Oh, there's no scale. You have to create it. Then what you should do is calculate the R value first. Now I can definitely tell this is a strong correlation if I wasn't sure before. All right, so, or if you did part B first and you said moderate and then you calculate Pearson's coefficient, then I would go back and change it. All right, and then calculate least squares regression line or line of best fit. So we should get y equals mx plus b. What did the equation come out to? I did not get a chance to calculate that.
Y equals 0.14x minus 3.61.
Perfect, minus 3.61. Thank you. All right, so that gives us our equation there. And then if you need to, you can go ahead, because this is kind of weird, and if you need to eyeball it to draw the line of best fit, if I ask you to draw it, then you just need to kind of figure out where you think it's going to go. And again, try and get half the points above it and half the points below it. So something like this, maybe. And if you can find the x and y means, you can also plot that point on your graph in a different color. I'll do it in a different color. But if I'm able to do that, oops. It'll say that my x mean was 62.8 and my y mean was 5.1. So 62.8, 5.1. So that'd be my like x mean, y mean right there. And that's always a good spot to put on your graph, and then you're trying to sketch the line through there, your line of best fit. Okay, so again, your calculator tells you all this information. You just need to know how to input it. That's the key.
The y mean is 6.1.
Yeah, I had the y mean is 5.1, sorry. Yeah. And then if a student scored 65 on the PSAT, what score should that student on the IB exam? Well, perfect. This is what happens when you don't proofread. What score should that student get? Let's say get on the IB exam. Still don't like that wording. So what you would do here, take the equation that you just found, and now we're going to actually plug in 65. All right, so even if you're doing all of your work on your calculator, really, really important that you're showing setups on the paper. This is what the IB exam is going to bank on, okay? If I don't show this setup right here, even though I'm doing everything on my calculator, then I'm not going to get full credit. The answer is, what do I get? 68.5, is that 75? That doesn't make sense. What did I do wrong? Is it 0.014 or not 0.14?
Should just be 0.14.
Times 65 minus 3.61. Oh, 0.14. Oh, you know, because I did times 65.
I got 5.49.
I did too. I'm sorry. I did that backwards. I did a plus 3.61 instead of minus in my calculator. So, but I knew the number didn't make sense because we're talking about a scale of 1 to 7 here. So make sure if you type it in your calculator incorrectly that you're like, okay, does this make sense in the context of the problem? All right. So yeah, we would just get 5.49. But again, if I just put it in my calculator and write this down, yeah, I'm going to get a point on the IB exam for the answer, but I'm not going to get any points for showing my work. And literally showing your work is just writing that line right there. That's the IB exam. That's how you get scored on the IB exam there. Okay.
Do we need to round for that one?
Yeah, I would round for it. Yeah. So always round to like the nearest hundredth, 3 significant figures. That's kind of a good rule of thumb if they don't specify.
But since it's like a score and the scores are like 1, 2, 3, 4, 5, 6, 7, do we need to round that to like a 6?
Oh yeah. So because it's 5.49, I would say that's a 5, because it would round down. So write down 5.49, and then you justify your answer after that. The student should score probably about a 5 on the IB exam. Yeah, this is kind of a bad number to use just because it's so close to the middle. So I probably could have picked a different score than 65. But yes, you'll want to explain why you rounded, yeah, in your part of your answer as well. Or at least just say the student should score a 5. So you recognizing there's a context to the problem, which is good. A very good thing. All right. Did you guys, if you haven't started number 2 yet, or did you already start number 2? Started it? Cool. All right. Okay, got it.
So for part C2,
Mm-hmm.
it shows the y-intercept, and that would be relevant because wouldn't that just be showing like the original length of the spring with no weight on it?
Yeah, I think you could say that, yes. Okay, as long as it's a reasonable number, like if, because sometimes these things break down outside of our data set. So, yeah. Okay.
Well, it is outside of our data set, but like it makes
Yes.
sense.
Yeah, if it's that's what I mean. As long as it still makes sense, as long as the number of the value of b is not insane. Yeah. All right. So what did we get for the r value for the correlation coefficient? For problem 2.
0.954.
0.954. So it's a very strong correlation. All right. And again, just from looking at the R value, you can see it's a positive correlation as well, because it wasn't a negative 0.9. And then find the value of A, the equation line of regression. And then again, you should be able to put that into your calculator to calculate it, and then comment on its meaning. Okay, so what did we get for A here? I did not put that in my calculator.
0.09.
0.809. 0.8?
No, just 09.
Oh, 0.09, sorry, yeah.
You're good.
0.09. All right, and then comment on its meaning. So remember, this is slope, or you might see the word gradient on a test. So find the gradient or the slope. And what's this slope telling us? This 0.09, saying basically every time we add weight, the spring is going to condense just a little bit, right? The length of the spring is going to shrink just a little bit by this much, okay?
Wouldn't it be getting bigger?
Oh, it's getting longer, I'm sorry, because we're hanging a weight from it, yeah. Sorry, I used to work in an industry where we put weight on springs because I worked in vibration isolation. But yeah, so this is the opposite. We're hanging the weight from the spring. So every time we add weight, the spring gets slightly longer.
You increase increase the weight by 1 gram and you increase the length of the spring by 0.09, right?
Exactly right. That's the perfect answer. Yes. That's what we want to say. If we're using the numbers to explain the relevance. And then the B value we ended up with for this one was, what did we get for the B value? I had my stats list for the first one in my calculator, not the second one.
18.07.
18.07. Thank you. And that, yeah, hopefully is saying that the spring should be 18 centimeters with no weight on it. And then, does that make sense? And I would say yes for this one. Like, if you got an answer that was like negative 18, is it possible for the spring to be negative 18 centimeters in length? No. So sometimes these models do break down, but this one looks like it's holding true. All right. That's the idea
Mr.
here.
Street?
Yes.
When commenting on the correlation, do you want us to say if it's linear or non-linear too?
No, I think it's fine if you just do strong positive, moderate positive, weak positive. I think that's perfectly fine. Okay. As far as linear, non-linear, I think, yeah, you know. This one, I think, is very much a linear one. The first one, I think the first one was kind of linear as well. But yeah, I don't really care too much about the non-linear, linear. What I was seeing on the IB exam when I was looking at it, the old IB exam questions, I didn't see anything that was specifically asking for that. So I think it's fine. Okay. Problem 3, piecewise function. I've just gone ahead and added a bunch of variables here. So like there's an A, a P, a Q, an S, a B, and a C. Find those values. All right. Do you guys need a minute on number 3 here? Are we good? All right. So for number 3, it says like identify the value of A, and it's showing that the domain or the list of numbers is going from somewhere and ending at 3. So it's right here. This is the first one. And it starts at 0. So we know P is going to be 0. And then A would just be the line y equals 3. So A equals 3. That takes care of our first couple variables. The second line, going from Q to S, is going to be this length right here. It's going from 3 to 5. So Q equals 3, S equals 5. And then we already had the equation negative x plus 7. If I were asking you to find the equation, then you could just work backwards. You can kind of draw the line backwards like that. Oops, is that right? Oh, you know what it is? I put the wrong equation in there. It should be negative x plus 6. That's my fault. All right, so it should be negative x plus 6. And yeah, you can tell because you can see the slope going back -1. So left -1, up 1, left -1, up 1. And just trying to figure out where that line's going. So that's problem 3 there, or the second one there. And then the third one, bx plus c, I'll highlight that one in red. First, we can figure out the domain 5 to 7. It's already done for us. The equation itself, we would have to, again, we could extrapolate the line backwards. It's going 2. And we're not going to be able to see the y-intercept, unfortunately. But what we can figure out is the slope. It looks like it's going up 2 over 1, up 2 over 1. So we know that we know b is equal to 2. And then we just take a point that's on that line. So for example, right here we have this 0.5 comma 1. We can say y equals 2x plus c, and to solve for c, we would just plug in the 0.5 comma 1 and figure out what c is. 1 equals 10 plus c. Subtract 10 from both sides, and we get negative 9 equals c. So that one's kind of a weird one, but in terms of the end, but that's just old algebra skills to kind of figure out that this is going to intercept at negative 9 down here. All right, and I did see an IB question with this type of problem on it where it did ask you to go back and solve for this equation, which is really a prior knowledge thing. It wasn't something we covered directly in this class, but it is something you've done in previous math classes for sure. All right, and then the last two problems, find the following values, f of 2. So when x equals 2, what's y equal? F of 2 equals 3. And then the other one, f of 7, when it's way over here, f of 7 equals 5. You're just trying to figure out where those values are. All right, that's the idea for the piecewise function. Okay. All right, problem 4 and 5, I'm going to give you guys about 10 minutes. Problem 4 is a very long one, and this is an actual IB question. I pulled this one straight off an old IB exam. Problem, all of this information at once. So for problem 4, you just have to break down the information. What's it telling us? One of the things here, hey, we've got this P equals A times N plus B, which is really just y equals mx plus b in disguise. Or in this case, there's an y equals ax plus b. So you're just trying to figure out what's a and what's b for this problem. So you would start by putting your data in, and then you're going to calculate your line of regression. That's what part A is asking you to do. So put your data in and then calculate your line of regression. Okay, so if you recognize that as just the ax plus b in general, that's it. All right, and what did we get for our line of regression for this problem? I have the answer on my computer, I just don't remember it off the top of my head. I'll pull it up.
It's 10.2x minus 1460.9.
Okay, oops. $14.629, yeah.
1460.9.
Okay, sorry. I will fix that. All right. Let's see. I don't think I had 10.2 though. My answer I had
something different.
I had 6.96 for my A value. And I had so we just got to be careful there. Yeah. So 6.96 and then N minus 455. I had something like that. It was like 454.805 was my B value.
Which numbers did you use to fill in the stat chart?
We should be using the numbers at the very top, the number of bees and the monthly honey production in grams, right? That should be the very top.
No, that's what I did. I don't know why it did it weirdly.
I was gonna say it could just be typing in a number incorrectly. It could just be as simple as that. I mean, that's what I did on problem 1. Was I typed 1 in incorrectly. So I got, yeah, it was like 6.96103. The B value is negative 4.54.805, something weird like that. And then part B, once you have that regression line, now use it to determine the monthly honey production of 270 bees. So now we would just say P equals 6.96 times 270 minus 455. And again, you have to write that line. That's going to get you full credit. And then you figure out what your P is. I think it came out to 1424.67. And then we can round. So approximately, and again, the IB exam usually rounds to 3 significant figures, so they'd probably say something like 1420, but it'd be perfectly fine if you just rounded to the nearest whole number and said 1424, if it doesn't specify, and this problem does not specify. Okay. So I would accept either 1420 or 1424 for this one, just depending on the rounding. All right. But like I said, the IB exam, they usually say 3 significant figures, so you would just put zeros after all of that. So 142 would be our 3 sig figs. All right. For part C, write down the number of low-producing hives. I kind of talked about that one already. Oops. I'm going to... And that would be, looking at our graph here, we have this P is less than 1080 right there. So we want to look for 1080, which is going to be right around there. And then we look for the corresponding X value. And it comes out to 40 right there. The point, it was this point right here at this intersection. Because this is counting by 40s. 40, 80, 120, 160, 1200. So that's part C. You would just say 40 hives.
So for that first one, is it the cumulative frequency? Because I still am trying to figure out what I did wrong.
Oh, for at the very top?
Yeah.
So, I don't know, like, did you delete your old data set, the numbers that were below it on the stats from your previous problems?
I have, like, it's deleted from the previous problems, but I'm checking the data again and it looks right.
Yeah, I don't know. We'll have to take a look at it at the end of class and see if we can figure out what was going on with it. And then I'll see if I can help you out with that. Okay. But yeah, it should just be these values here. I'm gonna put it in my calculator one more time.
It's weird because I also got 10.2 and I can't figure out. Maybe I made the same mistake that Ashley did. I don't know.
Okay. Yeah, I don't know. I made sure I'm in degrees and all that stuff. And it's like...
Yeah, it's not a degrees issue, so that's weird. 1500, 1700, 1800, bam. Okay. And then I'm going to do...
the 190, 220, that's in...
That's weird, because I just put it in my calculator, and I got 6.96 and negative 455. So I'm curious why it's giving you different answers. Did you switch the columns on accident? Because the number of bees should be list 1 and the monthly honey production should be list 2.
Yep, that's what I have.
Okay. I don't know. We'll take a look at it at the end of class and try and figure out why that's not quite working. But for right now, let's power through and then we'll talk about it. For part D, this is a weird one. When I was looking at it yesterday, I kind of got stuck on finding the value of k at first too. And the reason is because there's a line right here that actually helps with part D. When it says Adam knows that 128 of the hives are regular producing. And now we know there are 40 that are low producing. And the total number of hives is 200. So what we have to do then is we have to say 40 plus 128 equals 168. All right. So there's like 168 hives have production that's less than K. Okay. And what that means is we want to go up here and look for, on our cumulative frequency curve, look for 168. And now I can just scroll over. There's gonna be a point right there. And it looks like it's gonna be somewhere around there. So like 1640, because again, we're counting by 40s there. So K equals 1640. That's kind of a weird one, but for me, it was because I was like, well, how do we know how many regular hives there are? And then, oh yeah, they gave us that information. Like I said, the IB exam, they give you a ton of information at the very top, and then they ask you to work through everything. And then the final part, find the number of hives that have a high production. So we had 200 total. We subtract 168. There's going to be 32 left. And again, just showing your work on these parts, like, hey, this is where I got 168 from, this is where I got 32 from. Showing that work, and then drawing these lines on your cumulative frequency curve, that's going to all work towards giving you full points on an IB exam. All right, that's the idea with problem 4 there. All right, and I'm going to try and help you guys out in a minute here. Once we get through problem 5, I'm going to try and help you out with your calculators why we're not getting that one correct for some reason. Last one, problem 5. It says this data represents the number of students signed up for leadership at Sunset over the last 11 years from 2009 to 2019. So we had 54 students, then 60, 65, so it's growing each year. Create a box plot of this data. So that's the first thing you're going to want to do. And there's 11 years of data, so we'll want to find the median first. 1, 2, 3, 4, 5, 6. There's our median. Is 69. And then we'll want to find the first quartile and the second quartile. So first quartile is going to be 65. That's our Q1. Q3 is going to be 1, 2, 3, 73. There's our Q3. Drawing a box and whisker plot. We'll just create a line here. Started at 54, 56, 58, 60, and we'll just count by 2s until we get to 76. $74, $76. All right. And now our Q1 starts at 65. Our median is going to be at 69. Our Q3 is going to be at 73. And that's how we would draw our box and whisker plot for this particular problem. All right. So now, like, number 5 is showing us that we're starting to get into review. What's the interquartile range? Again, very simple to show your work on these problems. Just write down Q3 minus Q1. And then plug it in your calculator. The interquartile range is going to be 8. Calculate the mean of this data. So you just add them all together, divide by 11. All right. And if you're not sure if you should show your work or not on this one, again, you can just do it real quick. So you're showing that you know how to do it by hand. But in reality, if you put it in your calculator as a list, it might already be done, which would be kind of nice. And we should end up getting 68. All right. And then after adding the class of 2020, the mean is now 70. What is the number of leadership students in the class of 2020? Last one there. So basically, we have the mean 70 equals this. I think if we added all of them together, it was 54 plus 60 plus 65 plus 66 plus 67 plus 69 plus 71 plus 72, 73 plus 75 plus 76 plus x. All divided by, now it's going to be 12 because there's 12 points instead of 11. And what we can do then is we can just add them all up and we get some big number. It came out to 748 plus x equals 12. You're going to multiply 70 times 12. You're going to just work backwards to solve for x. You're going to get 840. So then you have 840 equals 748 minus x, or plus x, and then you subtract 748 from both sides, and you get x equals 92. That's how you'd find the last data point, the newest one. So there would be 92 students in the class of 2020 in leadership. All right, that's the idea for that. But again, problem 5 is a great example of specifically learning target 3 or learning target 6 descriptive stats. Problem 4, also with that cumulative frequency curve, that revisits the stats as well. That's the first couple of problems on problem 4. All right, so a little bit of review intertwined in with the new stuff as well. Okay. And that covers everything from the worksheet today. The assignment, if you guys want to stay on for the last 10 minutes and start working on it, that's perfectly fine. We do have the assessment tomorrow. I haven't figured out a new system yet, so I'm going to use Go Formative again. If it is a serious problem for you, let me know. I have not gotten to those surveys yet from last Wednesday. I'm going to look over those and make sure we can get some fixes if we need to. And now we'll try and figure out